So for example number 2, what the textbook wants us to do is consider a group of 4 kids, one boy and 3 girls, and a teacher is going to randomly select one person to be a speaker and one person to be a recorder. So then we have to create a sample space to determine if selecting a girl first and then selecting a girl second, if those are independent events. So when we do the sample space, it should be very clear that they are not independent events, okay? Um, that should be kind of clear. But anyways, we'll go through it and do it anyways. So on the first one, we're going to do, well, first let's identify. So we're going to have one girl, girl 1, girl 2, and then girl 3. That was kind of bright, wasn't it? And then just the boy. So that's what we're going to use for our sample space, right? So we've got girl 1, girl 2. So if I'm going to select one girl, then that would be girl 1, boy, girl 2, boy, or girl 3, and then the boy. So that gives me one girl, one girl, one girl. So that's for the first person. And then selecting the second person, if I have girl 1, then you could still have one girl, but on the first selection I might pick a boy and then pick girl 1. Does that make sense? So I'm gonna, these two are the same, right? If I'm talking about how, if order doesn't matter, that's a possible. In other words, I could pick a boy first if I randomly select them. Like maybe I have a spinner or something like that that randomly chooses. And then I could have the boy and the second girl and the boy and the third girl. So those are my scenarios for having only one girl. But I need to find out what happens with 2 girls, right? Because I'm only choosing 2 girls. I don't need to know if I'm going to choose 3 girls because I'm only choosing 2 people, period. All right? So same scenario, except now I'm going to have girl 1, right? And then I might have girl 2. And then that would be the same, I could possibly select girl 2 first and then choose girl 1. And then this would be girl 2 and girl 3, or girl 3 and girl 2, right? And then I could get girl 3 and girl 1. We don't have that combination yet. Or girl 1 and girl 3. So to determine whether these 2 events are dependent or not, we have to look at the probability of basically there being the first girl. In other words, determine whether selecting a girl first, what's that probability? So we're going to say first, a girl first. So to determine this probability, I have to know the total number of outcomes. So if I count all these up, I've got 12 outcomes total. And then what I have to do is figure out how many have a girl first. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 over 12 reduces down to 3/4. Okay. And then we need to figure out the probability of selecting a girl second. In other words, what's the probability of the second person I choose being a girl? Again, we have 12 possible outcomes. And then I got to count in the second column how many G's I've got. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, I got 9 over 12. So I've got 3/4. But the question they're asking us is, use the sample space to determine if selecting a girl first and selecting a girl second is independent. Oops, forgot to write that down. In other words, are the two events independent? Does it matter if I select a girl first or second? So I have these two probabilities, and then what I need to determine is what's the probability of selecting the first and second being a girl. Okay? And I wrote it kind of funny because I'm trying to read it out of the textbook. So again, I have 12. And what I got to do is I've got to count how many GGs I have. So I have 1, 2, 3, 4, 5, 6. 6 over 12 is 1/2. So in theory, if they are independent events, then the probability of A times the probability of B should equal the probability of A and B. In other words, 3/4 times 3/4 should equal 1/2. However, 3 times 3 is 9, 4 times 4 is 16, and it does not equal 1/2. So then we would say not independent. And I'm going to jump ahead a little bit and explain why. See, when I had to do the sample space, when I pull girl 1, that only leaves me with 2 other girls. So who I pull the first time really determines who I'm going to pull the second time. So when I pull girl 1, that means I only have 2 more options. I could pull girl 2 or I could pull girl 3. That's it. Those are the only 2 scenarios that I have. So who that second girl is depends on who the first girl is. And so when I have to say one depends on the other, we would call that a dependent event. And that means it would not be independent. Some textbooks talk about being mutually exclusive. But I don't want to dive into that just yet. Okay? So because the second person depends on who the first person is, then these are not independent events.